All right, welcome back. Polynomials, they can look kind of intimidating, right? Just a jumble of letters and numbers. But what if I told you they're actually a secret code? Yeah, seriously. They're the language behind stuff we see every day, like the curve of a roller coaster or the graphics in your favorite video game. So today, we're going to grab our decoder rings and crack that code by uncovering one of their biggest secrets. So let's jump right in with the big question, the one that unlocks everything else. What in the world is a polynomial's zero? It sounds kind of mysterious, doesn't it? But trust me, it's the absolute key. Okay, so here it is, plain and simple. A zero is just the special number you can plug in for x that makes the whole polynomial expression equal, well, zero. And if you're a visual person, think about a graph. A zero is just the spot where the graphed line literally hits the ground. You know, that flat x-axis. All right, first up, let's talk about the most straightforward way to find these zeros. Honestly, it's the easiest one. We're just going to use our eyes. And the rule here? It could not be simpler. You just have to count. That's it. Just count how many times the curve crosses that horizontal x-axis. Whatever that number is, that's how many zeros you've got. Okay, check out this first graph. See how the line is just kind of floating? It's parallel to the x-axis. It never, ever touches it. So how many zeros does it have? Yep, you got it. A big ol' zero. Now, this is where it gets interesting because you see it with all sorts of different shapes. Look at the graph on the left. The curve just dips down and kisses the axis in one single spot. So that's 1, 0. Easy. But now look at the one on the right. Whoa, it's weaving through, let's count, 1, 2, 3 times. So that one has 3 zeros. And guess what? This pattern just keeps on going. A graph could absolutely hit that axis 4 different times, which would mean it has, you guessed it, 4 zeros. It's such a simple but powerful visual clue you can spot in like half a second.
But, spotting zeros on a graph, that's kind of like level 1. So let's level up. It's time to crack this code using the real power tool, algebra.
I mean, having a graph is great, it's super helpful. But what happens when you don't have one? Well, that's where algebra steps in. It becomes our go-to tool for hunting down those exact x values that make the polynomial hit 0.
Let's take a look at an example. We've got the polynomial x squared minus 2x minus 8. Now, through a neat little process called factoring, we can actually break this thing down. And when we do, we discover that if you plug in a 4, or if you plug in a -2 for x, the whole expression becomes 0. And there you have it. Those are our zeros, found with algebra. Okay, but here's where it gets really cool. There's this secret pattern, this hidden connection between the zeros we just found, that 4 and -2, and the original numbers in the polynomial. You know, the numbers right in front of the variables? Those are called coefficients. Just look at this table. It lays it all out. If we add our zeros together, so 4 plus -2, what do we get? We get 2. Now, look at the formula that uses the coefficients. It also gives us 2. It's a perfect match. And it's the same thing for the product. If we multiply our zeros, 4 times -2, that's -8. And the coefficient formula? Yep, also -8. This is not a coincidence, people. It's a core rule of how these things work. And you want to know the best part? This secret code works backwards too. That means if someone just gives you the sum and the product of the zeros, you can actually build the entire polynomial right from scratch. And it's a super simple 3-step process. First, you start with this general formula. Then, step 2, you just plug in the sum and product they gave you. And finally, you do a little bit of tidying up, a little simplification, and boom, you have just built the exact polynomial you were looking for. Okay, it's time for our final tool. This one's the big one. For those really complicated, messy polynomials, we need a kind of master key. And that key, believe it or not, is division. Because let's be real, sometimes you're going to run into a polynomial that is just a beast. It's too tricky to factor the easy way. So, what do you do then? How do you break it down? Well, we use a technique called polynomial division. And honestly, it's going to look a lot like the long division you did back in grade school, but, for polynomials. Its number one job is to let us check if one smaller polynomial fits perfectly inside a bigger one. In other words, if it's a factor. Just take a look at this example here. We go through all the steps of the division, and then look at that final number at the very bottom. What is it? It's a 0. That right there is the magic number we're looking for. Because when that remainder is 0, it's like a signal.
It tells us the division worked out perfectly. It's confirmation that the polynomial we divided by is for sure a factor of the big one. It's a perfect, clean fit.
But now, look at this other example. We do all the same work, go through all the same steps, but this time, we're left with a remainder at the end, and it is definitely not 0.
So the rule here is just about as simple as it gets. If your remainder is 0, you've got a factor. If the remainder is anything else, literally anything, then it's not a factor. This one test gives you a clear, definitive yes or no answer. No guessing involved. All right, so let's do a quick recap of the awesome new toolkit you've got. First, you can spot zeros just by looking at a graph and seeing where it hits the x-axis. Second, you can find them using algebra and even double-check your work with that cool coefficient secret code. And finally, for the tough ones, you've got polynomial division as your master key to check for factors.
So it turns out polynomials are just filled with these amazing patterns and secrets. And today, you've basically been handed the keys to start unlocking them all. So really, the only question left is, what are you going to solve next?